I would like to invite you to take a few minutes and listen to a recent conference call between one of our executives and the science expert behind the technology of EnviroTabs. It only lasts about 17 minutes, but is packed full of answers to the questions you may have about exactly how our product works. Come on, I will listen in with you, and then I'll be back to say goodbye.
Why don't you just tell everyone a little bit about your background as it pertains to the combustion catalyst?
Academically, I have a doctorate in biochemistry and a secondary degree in chemical rheology, and went to work with those two degrees for the government, working on catalyzation products which developed into this chemistry. Not something solely on my own. The government was using it for a lot of other things, but I saw some interest in it, so we took it a step further, and over the last 27 years of manufacturing fuel additives have decided that this technology in particular was the foremost that's available in the United States and basically in the world right now.
All right, well, that's wonderful. How did you get involved in this particular science and this particular technology?
Did some research with the government on using it as a rocket booster, actually as a missile booster for the Department of Defense with a contract we had when we first started our own private sector business.
And, okay, so explain in lay terms, if you would please, Steve, how and why does this product work?
Well, unlike other fuel additives, it is a catalyst, and it's not a catalyst for fuels, for the liquid fuels themselves. It's actually metallurgy and has a reaction with what's called, in this case, the fire deck, which is the metal surface in a combustion chamber in an internal combustion engine. It's very similar to what's used in the rocket boosters, open flame boilers, et cetera, et cetera. But again, the product relates to metallurgy, not to chemistry where you'd be altering the fuel. And it does work by forming a very, 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 very thin coating somewhere below 800 angstroms. This catalyzes the metal. In other words, you have to picture the whole fire deck as an envelope, and that's what you're altering. You're altering a moment in time when the fuel detonates. You're not altering the fuel. So the catalysis takes place in the combustion chamber, and you've actually formed a condition in the combustion chamber on the surfaces of the fire deck. That's all of the metal surfaces that are exposed to the detonation or the combustion. And you're catalyzing that space and time, that actual combustion process. You're not catalyzing the fuel reaction itself. You're altering the combustion chamber. And that catalytic coating, if you will, the precursor is what the EnviroTab is. So as you continue to put that into the fuel, it's deposited on the fire deck, and it is sacrificial. It will only last for a while. That's why you have to replenish it by consistently using the product. But again, it catalyzes that whole process of the combustion chamber, not the fuel itself, and allows the product to act as a catalyst and change the way the combustion occurs within the combustion chamber by quickening the rate of combustion of hydrocarbon fuels.
And how has it been proven effective? Can you talk a little bit about some of the testing and the data?
There are basically several people who were involved, let's say 25 years ago, when some of the technology came to light. And in that time, when the EPA was forming its fuel registration systems, these 3 or 4 people that were involved had done a significant amount of studies. There have been several patents, even some expired now because of the age. Well over 400 million miles of tests of various commercial blends in the U.S., again, used by the government. It's a very substantial technology. The use of it in the engines is a minor portion of what the material can really do in other applications. But again, it's been used significantly in different variations, and the technology continues to go on. Fortunately, it's regulated by the EPA, and only a few people can play. So it's quite novel.
So we talk about on the label of the EnviroTabs, reduced emissions. How does it reduce emissions?
Well, essentially, as we said a second ago, it causes hydrocarbon fuels to ignite faster. So from the point of detonation of the fuel, with the fuel igniting faster, the long-chain hydrocarbons that usually burn slower and create particulate emission issues burn rapidly, therefore lowering the particulate emissions that you're asking about. In addition to that, because they do burn quicker, less nitrogen or nitrogen byproducts produced, which are the NOx and the non-particulate emissions that everybody's concerned with right now.
So basically, more fuel is burning in the power stroke, less is therefore having to burn in the exhaust stroke, so you're getting less emissions. Would that be a fair lay statement?
That was well put. It's approximately 30% increase in downstroke efficiency.
And same thing for saving money, getting better mileage. Is it the same benefit?
Right. Well, you have that approximately, again, 30% increase in downstroke, and that can be translated into quite a savings in mileage, again, depending on how you drive as well. If you have a heavy foot, not going to be as beneficial as if you just drive normally. Because the combustion is enhanced, yes, it's a tremendous savings in mileage.
Now, that's interesting because now it's getting cold in a lot of part of the country, so we're having different weather, and we're also getting different blends of fuel. How is that going to react in terms of fuel mileage as the seasons change here?
Well, keep in mind, again, this is metallurgy. It has no effect on the chemistry of the fuel. So as long as the material is carried into the combustion chamber, the benefits are there, whether it's hot weather, cold weather, it really doesn't matter.
But we will see some people's mileage go down in the winter or with a winter blend.
Of typical fuels, yes.
Correct. Okay. So I just wanted to just kind of let people know that if they're doing a base test, for instance, in September, and then they're put the catalyst in October, but there's a 30 or 40 degree temperature change, or they've begun to change the fuels to winter blends, they have to be aware of that. There are different variables on the actual mileage you're going to get. Doesn't mean the product's not working, just means those variables have an effect on fuel mileage.
Right, especially in fleets and trucks and diesel engines that are using the new low-sulfur diesel fuel. In the winter, that low-sulfur fuel has an even larger percentage of pour-point depressants added to it to keep it from freezing or gelling in the winter. And that larger percent, fortunately, does not carry the cetane value that the regular diesel does. But what you're saying is exactly true. They're going to drop off the percentage of mileage simply because it's a different fuel.
All right, good to know. Let's talk about the fact that you can actually go from a premium fuel to a regular fuel by using the product, but that alone saves 20, 30, 40 cents. All my vehicles say use premium only. I've been using only regular, and the car runs beautifully. Why is it that you can use a lower octane fuel with the product and still get great results?
That is an excellent question. I'm glad you brought that up. The whole purpose of premium fuels is simply to have a higher octane rating or a higher octane number. And the higher octane is simply to provide more power in a very cheap and economical way to the vehicle. By using the EnviroTab and getting that increase in the combustion characteristics, you no longer need that extra octane to do it because the product is now handling that. You're getting the performance without the expense of the added octane boosters that are used in the premium fuel.
So bottom line is anybody that's using premium can now use regular and have a better performance in the vehicle, and that's a savings, actually a large savings on its own.
Exactly. I mean, again, that's why it's a very good point. That's an excellent savings in its own with everything else aside.
Now, it's interesting because for many years we used to say, if you give me $2 for this product, I'll save you $5, $10, $15 at the pump. But when you stop and think about what you can save in maintenance costs because of the engine lasting longer and because of the oil lasting longer, it's a whole lot more than you give me 2, I'll give you 10. It could be you give me 2, I'll give you thousands of dollars in saving. Can you talk a little bit about lowering maintenance costs, longevity of the engine, and why?
Certainly. Again, because it's a metal technology, and that quote-unquote thin film is formed, it accomplishes several things. It can eliminate popping holes in the top of a piston from overburning and the thermite reaction of other ingredients that are found in commercial pump fuels. It reduces technically what everybody's calling head wear lately, which is just wear around the valve seats and so forth. Now, an interesting thing is an early version of the material was actually used by a couple of major players in the fuel industry to replace lead until the no-leaded fuel situation was squared away as a valve seat material, which it still works, obviously, in that function and reduces both valve wear and valve seat wear because of that. It will also, because it causes unburned carbon deposits to burn off, lengthen the life of the rings on the piston. You will get less blow-by over only a few thousand miles. The rings will clean up tremendously. In tests that have been done with major engine manufacturers, if you take an engine that's not treated, comparative length of time and miles of an engine that is treated, you'll notice the treated engine looks brand new. It's pretty amazing. So there's a lot of money that can be saved in wear and tear, and again, especially with commercial vehicles that suffer harder extremes in how they're used and so forth.
So unlike detergents that may clean the hard carbon deposits off but then drop those little, essentially rocks into the oil, which act as almost a sandblast of the engine, this is burning the carbon off, and therefore engines can last significantly longer, and oil changes can be reduced, which is